When I first heard about the requirements of the system, I thought it was impossible to build such a system.
The heart of any interferometer is its correlator. We are currently in the wide arc correlator room, correlator for the EVLA. We are here now with Michael Rupin, the EVLA's project scientist for the correlator, and Brent Carlson, the design engineer. Each antenna sends to this room about 120 gigabits of data, which have to be processed in real time with the signals from all the other 27 antennas in the array. We're standing in front of the baseline board, which actually does the cross multiplies between all the antennas.
Signals come in from each antenna and you have to multiply the signals from one antenna by the signals from another antenna. That's what these individual boards do. Because we have 27 antennas, each of them producing about 128 gigabits a second, we have to do a lot of such cross multiplies, and we have to divide up the work amongst a lot of different boards. So we have 128 of these individual boards, and Brent will pull them down.
So on each one of these boards is a number of integrated circuits. On this board is about 180 devices, each device anywhere from 250 to 600 and some pins. And on the front side is a heat sink that keeps it all cool. But on the front side is the same sort of array of chips.
So Michael, how much data comes out of the correlator compared to how much data goes in?
So what comes in is about 2.5 terabits a second, so it would fill the terabyte drive in about 3 seconds. What comes out is up to 128 gigabytes a second, which would mean something like 4 DVDs a second.
And where does all this data go after it's taken from this correlator? It has to go to some big pool somewhere.
So from here it goes to the correlator backend, which groups together the data from all these boards, sticks them in one big file. From there it goes to a local storage area. From there it goes to a more permanent storage area with lots and lots of disk space. And from there we send it out to the observers over the internet.
I see that we have different kinds of cables coming down here, red, blue, and yellow. What's the difference? What does the color mean?
These cables are for our Ethernet cables. The blue is used for monitor and control. Should you hang on to that handle?
Don't drop that.
Blue is used for monitor control. The red is the output data, and the yellow's for phased output data, where you phase up the entire array and use it with other radio telescopes around the continental US.
I'm correct to say that this is a special purpose computer, right?
It's a special purpose supercomputer. It does about 10 to the 16, 32-bit operations per second.
So can we put that into terms that a non-digital engineer can appreciate?
It's something like 5 to 10 times faster than the fastest general purpose computer in the world.
Right, and the difference is, though, this is a special purpose computer, so it's designed to build one thing.
It does one thing really, really well and really fast.
I refer to it as a rear engine dragster. It has one purpose and one purpose only.
And it burns a lot of rubber, right?
Yes, that's right.
We are at an elevation of 7,000 feet, which this is an air-cooled system, as anybody can hear. Was there an issue on keeping things cool? What is the operating temperature of the system?
Well, we try and keep the junction temperature of all the chips less than 50 degrees, because at that temperature, plus or minus 10 degrees Celsius is a factor of 2 in reduction in reliability. If you went to 60 degrees, you'd be a factor of 2 reduction in reliability. So for a system to last 20 years, you want to keep things as cool as reasonably possible. We did put a lot of work into reliability testing of the chips. We did a commissioned reliability study of the chips, and they put it through a whole bunch of shake and bake kind of tests. We also commissioned a manufacturer to look at the circuit board and beat it up, and it's a very robust circuit board as well. You know, this whole system, the EVLA, the correlator, everything is definitely not any single person. There's a whole team of people behind the whole thing, and it's all the collective effort that's resulted in this.